All right, back again, starting with number 8 from the Test 3, Math 107 Test 3 review. It says, if a one-person household spends an average of $40 per week on groceries, that seems cheap, actually, right? That's our mean mu. Find the maximum and minimum dollar amount spent per week for the middle 50% of a one-person household. Middle, or the average, I guess, 50%, the middle. So it's telling us where to shade. Assume standard deviation is $5, so there's sigma, and the variable is normally distributed. So we can apply our normal distribution formulas and tables and all of that in drawings. So let's draw the picture. This is from section 5.3 again. So the mean is mu of 40. The middle 50% of people spending, that would be, you have to split it equally on both sides of the mean. So 25% here, 25% here. That gives you the middle 50%. But as we've talked about in earlier questions, if I want to know these z-scores, I don't look up this part. I actually look up the tails, specifically the left tail. And we know in total is 100%. So we've accounted for 50% under the curve here. So we have 50% left over, 100% minus 50%. So that's on each tail then, we would have in each tail 25%. So specifically to get a z-score, it's best to look up the left tail. So I'm going to look up 0.2500, changing that into an area. So what I'm looking for is 0.2500, the closest area, hoping for an exact match, but it's not likely, to 0.2500. Again, going through the areas here. So I find the first 0.25 in my table here, right here at 0.2514. That's a little too big. 14/10,000 is too big, bigger than 0.2500. So I look to the left. 0.2483 is too small. That's 17/10,000ths away. So this one's closer. So I'm going to use negative 0.67 for my z-score on the left side. So this z-score on the left is negative 0.67. However, I also need to work with this z-score on the right, which is positive 0.67 because of symmetry, and I need both. So how much do people spend on groceries then? And so now I'm going to use this other formula for the x formula, which is mu plus z times sigma from your formulas page for chapter 5 and 6 and 7. And so this formula I'm going to now use to find how much are people spending on groceries in the middle 50%. So I'm going to take x equals mu, that was 40, plus z, negative 0.67, times sigma, 5. So order of operations says you multiply first. So I'm going to take 0.67 negative times 5. That's going to give you negative 3.35. So 40 plus negative 3.35. This is money. So this would give you 36.65. So I'm going to do the same here. I'm going to solve for x for the positive z, 0.67. So I take x equals mu 40 plus z 0.67 times sigma 5. I'm squeezing that in there, sorry. So we have 40 plus, when I do that multiplication, 0.67 times 5, I get 3.35. And so that's going to give you 43.35. So the middle 50% of people in terms of grocery spending with this data are spending between $36.65 and $43.35 per week. Sounds cheap to me, right? But I guess it's for one person. So going to number 9. Number 9 says to qualify for security officers training, recruits are tested for stress tolerance. The scores are normally distributed with a mean of 62, that's mu, and a standard deviation of 8, that's sigma. Only the top 15% of recruits are selected, find the cutoff score. So anytime you get percent, you're getting area, and there's some indication about where to shade. By saying the top means the highest. So in the middle is our mean of 62. The top or highest scoring 15% would be over here in the right tail. So we want to find z and then work our way back to x. What's the score on that test to put someone in the top 15%? So again, we never look up the area to the right. We need the area to the left. We know there's 100% total area under the curve. If I take 100% minus 15%, I'm going to get 85%. So changing that to a decimal, 85%, 0.8500. I'm going to look for that. Where am I? On the positive z side of the table. I'm hoping for an exact match, but usually there isn't when you're getting like kind of a whole percent like that. So I'm going to the positive z side of the table. I'm looking for 0.8500. So I'm going to the first 0.85 in my table, 0.8508. That's a little too big, so I look to the left, 0.8485. That's too small. This one's closer to 0.8500. So I'm going to use a z-score of 1.04. So that's my z-score, 1.04. Now I'm going to go to the x formula that we used up here in number 8 to solve for x. So we're going to take x equals mu 62 plus z we just found was 1.04 times sigma given was 8. So multiplying first, we're going to have 62 plus 8.32. So that's going to give me a value of 70.32. Would put a recruit in the top 15% on that test, people taking the test. So maybe you can't get 70.32. So that's why I put on the answer key, probably it's around a 70 on the test. That's closest to a 70 score, or 71, depending on how they round it, I guess. All right, on to number 10. All right, so number 10 says, a survey found that the American family generates an average of 17.2 pounds of glass garbage each year. That's our mean, mu. Assume the standard deviation of the distribution is 2.5 pounds. So that's sigma, 2.5. Find the probability that the mean of a sample of 55 families. So now we have a sample of size 55, that the mean of the sample will be between 17 and 18 pounds. So we have two sample means, 17 and 18. So let me draw the picture here. So the population mean mu is in the middle at 17.2. So now we're comparing our sample mean to a population mean. So 17 x bar is less than 17.2, so we're going to put it to the left. Don't have a really good feel about how far to the left, but it's smaller, so we'll put it to the left. 18 is greater, so I'm going to put that to the right. And it says to shade between in the problem, between that amount. So we're going to convert each of these into a z-score, but now we have to use the longer z formula. X bar minus mu over sigma over the square root of n. Oops, let me put this over here. Okay, so we have to use, when we're converting a sample mean x bar into a z-score, we have to use this longer z formula from the formulas page. It's sometimes a little tricky to put that in our calculator. So we're going to take x bar 17 minus mu 17.2 over sigma 2.5 over the square root of n 55. This should be negative because we're to the left of the mean. So this is negative 0.2 over 2.5 over the square root of 55. So if you cannot get this into your calculator correctly, you need to use parentheses, by the way. If you're having trouble to get the right answer, take the square root of 55 in your calculator, which is going to be 7 point something, about 7.4162 approximately. Carry like 4 or 5 decimal places. Write that down. But remember, you need these parentheses to make this work out. Otherwise, you're not going to get the right answer. So putting this in our calculator, negative 0.2 divided by left parentheses 2.5 divided by the square root of 55, right parentheses equals, I get negative 0.593. So I'm going to call that negative 0.59. Let me just double check that because it's easy to mess that up. Negative 0.593, yeah. So negative 0.59. So now I'm going to convert a data x bar into a z-score, which should be positive from the sample mean. So x bar 18 minus mu 17.2 over sigma 2.5 over the square root of the sample size 55. So this is going to give me 0.8 over 2.5 over the square root of 55. Again, you can't make this work in your calculator, take the square root of 55, carry about 4 or 5 decimal places. Be sure to use those parentheses though, and then put that in. So we're going to take 0.8 divided by left parentheses 2.5 divided by the square root of 55 right parentheses equals, we get 2.373. So it's going to be 2.37 because after the 7 is a 3. And again, let me just double check my math here. 2.373, right? Okay. So I'm going to look up those z-scores on the negative and positive z side, starting with negative 0.59 on the negative z side. So ignore that, sorry. And row negative 0.5 and then 900ths. I'm going to get this area of 0.2776. 0.2776. That's the area in the left tail. Because whenever I look something up, I get the area in, I'm going to let that stop. I'm going to get the area in the left tail when I look up negative 0.59. So now I'm going to look up 2.37 on the positive z side. It was a telemarketer anyway, bothering us when we're in the middle of something important. So I'm going to look up 2.37. So row 2.3 and then 700ths is going to give me 0.9911. And again, that is the area to the left. So all the way, 2.37, right? That all the way to the left, 9911, 2.37, yeah. So all the way to the left tail. So from 0.9911, I'm going to subtract the unshaded 0.2776 to get our answer. Let me go to my calculator. 0.9911 minus 0.2776. It's going to give me my answer of 0.7135. That's the probability that if we took a sample, a large sample of 55 American households, their recycling for the year would fall between 17 and 18 pounds. I feel like my family does more than that, actually. All right, so I'm going to stop here because I'm at 12.5 minutes, and I'm not sure I could finish number 10, or number 11 is a longer question, so I'll do that on the next video.